Looking at Khan Academy, I thought maybe a little review for quiz 2 on Khan Academy. Alright, so this first one that I have here, right, is you get two functions, f and g, and they're looking for, right, the limit as x approaches 1, right here. The limit as x approaches 1 of f of x over g of x. So what you want to do is you're taking the limit of each separately. So the limit as x approaches 1 here. So again, just to go over limits again, what does it look like it's the height of your function is going to be from the left and the right? And in this case, we could see that height of the function going to be 2. So that would be your limit for f of x. Now for g of x, when you're approaching from the left and the right, don't worry so much about that open circle. It's just what is the height of the graph looking like? It's going to be 0. When this happens, so a couple rules that I wanted to go over with you guys. If it is, right, so let's move to the side a little bit. 0 over 0, this means the limit exists. Okay? If it's any non-zero number, non-zero over 0, limit is either positive or negative infinity or does not exist. Okay? If it is 0 over any non-zero number, right, then your answer is just 0 because you're just dividing 0 divided by a number, which will get 0. So in this situation, we don't really know, we can't really do much work with this, so this is going to be does not exist because you get 2 over 0. If it was the reverse, you would just have 0 as your answer. Alright, so that was number 1. Number 2 on the review is something that looks like this, and I know you guys probably don't remember the table that we used early on in the school year. But again, when you're looking at this, think about plugging in -3, right? So if you go from the left or from the right. So let's do this separately. Let's say the limit as x approaches -3 from the left, right? And you have this function. And you plug in. So you wind up getting inside 0, but remember I'm going to just say from the left, but since I'm squaring it, it really winds up, that negative is really going to always wind up being positive. So because it is -5 over a positive, like approaching, now that it's changed to positive, you are going to get negative infinity. Okay, similar to that, if we did the same thing here, -3 from the positive side, you plug in that -3, you're going to get a 0, but now from the positive, squaring it doesn't really change much. So we have negative over a positive, which is going to give me a negative infinity. Since these two limits are equal, my limit of this original function is going to be negative infinity. Okay, so again, making sure the limit from the left is equal to the limit from the right, and then your limits are equal. Alright, next one. Okay, on this problem, again, same idea. So for here, for limit as x approaches 2 of f of x plus g of x. So really all you're doing here is the limit of each. You could break it up. And when you do that, the limit of f of x as x approaches 2, you could see that's going to approach 1. The height of the graph is going to be 1. But for g of x, it's going to be undefined or does not exist because you have that jump in your graph at 2. Or you could think of it as you're getting different heights, right? From the left side, you get a height of 1. From the right side, you get a height of 2. Okay, so in this case, our limit does not exist, which means that 1 plus something that doesn't exist still does not exist. Okay, so that is your answer for number 3. And then for number 4, if you get something like this, just keep in mind of what you're approaching, right? So since x is approaching 1, we want to do anything that would be greater than 0. So we're using this function, which means it's just going to be ln, it's the limit as x approaches 1 of ln of x, which is just ln of 1. And hopefully we remember that ln of 1 is 0. All right, hopefully that helps.